Hello everyone. Yeah, let's start today's class. So today's class may be very small session and we will be studying equation of the plane passing through three non-collinear points. Yeah, you can say equation of a plane passing through three given points. And of course, it given points to be non-collinear points. So let's start the class. Okay, so here you see, so we are given three non-collinear points. Yes, I have taken here let R x1, y1, z1 is x2, y2, z2 and t x3, y3, z3. These three given non-collinear points with position vectors A, B and C respectively. So here this is the origin. So OR vector equal to A vector, position vector of A. Then OS vector, position vector of S, that is equal to B vector, and OT vector, position vector of T equal to, yeah, so we have taken it as vector C. And P is any arbitrary point whose position vector is R vector. So it means P is a variable point. So it means you are having a OP vector equal to R vector, right? So let's find out the equation of the plane passing through these three given points R, S and T. Okay, so whenever you have OR, OS, OT, so you can see from here, okay, so if I write here, and we know line joining any 2 points in the plane lies completely on it. So it means if you have R and S 2 points on the plane, so RS vector will lie completely on the plane. Similarly, we have, I mean, RT 2 points on the plane. So it means RT vector will be lying completely on the plane. So whenever RS is a vector on the plane and RT is a vector on the plane, so it means the vector perpendicular to both these two vectors, or you can say vector perpendicular to the plane containing RS and RT will be obviously RS cross RT, right? So RS cross RT vector is perpendicular to both RS and RT vectors. Or you can say this vector RS cross RT is perpendicular to the plane containing these two vectors, right? So it means RS cross RT will be perpendicular to the plane. And here you can see when RS cross RT perpendicular to the plane, so as we know, any perpendicular to the plane will be perpendicular to all the lines or all the vectors contained in the plane. So it means RS cross RT, that will be perpendicular to, I mean, this vector also, if you take the other vector, so you can say RP. Okay, RP vector, are you able to see? This is perpendicular to RP vector. Okay, so this is the basic idea. Basically, I will be repeating once more. So before, we go to the formal definition, let me show you. So as we have been studying 3D geometry by using GeoGebra applet, we can see the, plane. Here the construction of the plane we can see. So here we have taken PQR. Yeah, I've taken here PQR 3 points. Okay, these are the 3 points. Okay, so you can see this is 1 point. C. Sorry, this is R. This is P, and this point is Q. So by move, yeah, you can see I am just moving these 3 points. You can see the plane contained by these 3 points. See, okay. And when I move P also, you see this. Okay, the same plane passing through 3 given points. Okay, this is by moving P point, you can see different positions of the plane only. You can see. So it means whenever we have these 3 planes, 3 points, sorry, 3 points. So through 3 non-collinear points, one plane can be formed. Sorry, or in other words, we can say, yeah, you can see. Okay, so whenever you have, okay. Okay, so this is basically I'm showing you here so that you can see for getting the plane, just like no, to have a line we need minimum 2 points. Similarly, to get a plane we need minimum 3 points. Okay, so earlier we have studied plane passing through a given point and the plane passing through a given point and the normal to the plane is given. How to find equation of that? Okay, so we have studied that. And here you can say, 3 points. Okay, the same plane you see whenever I am moving this R, P, then Q. Got it? Yeah. And here you see this is the normal to the plane. This yellow vector colored in yellow. So this is the plane basically which passing through these 3 given points, these 3 blue dots, I mean are given these 3 points. Okay, through these 3 points we are getting this plane. So this is basically how to visualize. You can visualize the plane like this. Okay, this is the plane, required plane passing through 3 given points. So let us go back to the theory portion and get the equation. Then maybe we can take some questions. Yeah, so this is the simplest concept. Now we have been studying this topic. Okay, so anyway, coming back to this thing, I have already told you, we are having RST 3 points, given points with position vectors A, B, and C, and which is OP is the arbitrary point this. Now, you can write it formally. So here you see, you can write RS cross RT is perpendicular to the plane containing RS vector and RT vector. Okay, which means RS vector cross RT vector is perpendicular to the required plane. Okay, the plane we want. Okay, so this is basically by using property, one of the properties of cross product of 2 vectors. So as we know, A cross B is perpendicular to the plane containing both A and B. Okay, now you see Yes, you can see RP vector also. RP vector lies on this plane. Okay, because R and P are points on that plane. So vector joining 2 points, yeah, line joining 2 points lies completely on it. So RP vector lies on this plane and perpendicular to the plane is perpendicular to each and every line contained in the plane. So this implies your RP vector will be perpendicular to RS cross RT. Okay, so if two vectors are perpendicular, what is the condition? RP vector dot RS cross RT. This is equal to 0. Two vectors are perpendicular, so dot product is 0. That means your RP vector is what? Position vector of P minus position vector of R. Means you are getting R minus A dot. So this is RS. So position vector of S minus position vector of R cross RT means position vector of T minus position vector of R. Okay, this is equal to 0. So this is basically, we can say, vector equation of the plane. Okay, vector equation of the plane passing through 3 points, 3 non-collinear points, 3 non-collinear points with position vectors A, B and C respectively. Okay, so this is basically the basics of the concept. Now to remember this, not very easy to remember every time, no? B minus A, C minus A like this. So as we have seen here, let's go back to Cartesian form now. So this is vector equation. So as we know, A vector is your x1i plus y1j plus z1k. B vector is your x2i plus y2j plus z2k and C vector is x3i plus y3j plus z3k and your R vector is, as usual, it is always xi plus yj plus zk. Now coming back from this equation, R minus A means what? You can say vector joining, R minus A means you can take directly this minus this. This is basically x minus x1 into I cap y minus y1 into j cap plus z minus z1 into k cap. Okay, I'm just putting this into the bracket. Dot B minus A means what? B minus A means this is your x2 minus x1. I can take the cross product directly. So this B minus A means what? x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. Okay. Similarly, C minus A would be what? x3 minus x1 I y3 minus y1 into j plus z3 minus z1 into k. That means we can write the cross product of this. It can be written like this. Okay. So this part I am telling you the concept part, but whenever you solve the question, it is very, very easy. We will be applying the formula directly. So it is I, J, K. Now here it is x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. Okay, determinant of this. So the way you find cross product of two vectors. So b minus a cross c minus a will be like this. Now if you simplify, if you multiply this, you know how to evaluate the determinant. Then whenever you multiply with this will give you x minus x1. Okay, so we have taken this dot this equal to 0, right? So it means this is equal to 0. So now if you simplify LHS, I mean you know how to evaluate the determinant. So I'm not going to that detail. So finally you can get, I mean this dot the vector obtained from this determinant, you will be getting x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. Okay, determinant of this equal to 0. Okay, so this will give you equation of the vector, sorry, equation of the plane in Cartesian form. So this is very very easy to remember. Okay, and also for vector form also you don't have to remember like this. So if you can find equation of the plane in Cartesian form, then from Cartesian form you can obtain the vector form also. I will take a question for you, then I'll show you how to do it. Okay, so let's take a question here. The another thing is there in case, yeah, any of you have studied scalar product, scalar triple product of three vectors, this will be very very easy for you. So maybe very soon I am going to upload a video on scalar triple product. You can refer to that. So that will really help you. These 3 points means three given points, and the fourth point is the arbitrary point. But basically how 4 points are coplanar. Okay, the scalar triple product which is deleted from the syllabus this year, so that can really help you. So anyways, I will be uploading a video on scalar triple product, so this may help you also. Otherwise, this is fine. Okay, find the vector and Cartesian equation. Okay, one question we can take. Find the equation of the plane in vector and Cartesian forms. Okay, Cartesian form. Yeah. If the plane passes through, if the plane passes through 3 points, 3 points given, 3 points whose position vectors are given by yes, 2i plus 2j minus k, 2i plus 2j minus k. So I, j, k invariably cap will be put. Yeah, it is 3i plus 4j plus 2k. 3i plus 4j plus 2k and 7i plus 6k. 7i plus 6k. Okay, so these are the 3 points given to us. Then we have to find the Cartesian and vector equation. As I told you earlier also, it is easier for us to find equation of the plane in Cartesian form, and quickly we can take the vector form also. So I will be using that method only. Maybe it will help you and you will feel very comfortable with this method. So given points, okay, given points are, so 2i plus 2j minus k means it is 2, 2 minus 1. Then here it is 3, 4, 2, and here 7, 0, 6. Okay, these are the 3 points. Okay, so equation of the plane, directly we can use formula. Equation of the plane passing through equation of the passing through these 3 points, passing through these 3 points is, you can write here, x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. The determinant formed by this equal to 0. Okay, so just 1 minute. Okay, so it means what we are getting here. So this implies x minus 2, y minus 2, z plus 1, right? X minus 3, sorry, x2 minus x1. So yes, x2 minus x1 means 3 minus 2. So 3 minus 2 is 1, y2 minus y1, 4 minus 2 is 2, 2 minus of minus 1 is 3. Okay, then x3 minus x1, 7 minus 2, 5, 0 minus 2, minus 2, 6 minus of minus 1 is 7. Okay, so the determinant equal to 0. Okay, so we have taken this, let us check before we evaluate. 2, 2 minus 1, 3, 4, 2, 7, 0, 6. So x minus x1 means x minus 2, y minus 2, z plus 1, right? Then x2 minus x1, 3 minus 2, then 4 minus 2, then 2 minus of minus 1, 2 plus 1, okay? Then 7 minus 2, 5, 0 minus 2 minus 2, 6 minus of minus 1 is 7. Okay, now let's find out. So this is equal to, we can evaluate this. Okay, so I can write here x minus 2 into, here it is, yeah, 14 plus 6, okay, minus of y minus 2. Now you can check here, it is 7 minus 15. 7 minus 15 plus z plus 1. So again here it is minus 2 minus 10. Okay, minus 2 minus 10, this is equal to 0. Okay. So I think with this simple concept, one question is sufficient. Okay, so 14 plus 6, 20. So we are getting 20x minus 40. minus, here it is 7 into 7 minus 15 minus 8. So I can write here plus. So you are getting here 8y minus 16, right? Now minus 2 minus 10 minus 12. So minus 12z minus 12 equal to 0. So you can write quickly 20x plus 8y minus 12z equal to what? Minus 40 minus 16 minus 56, right? Minus 56 minus 12. Yeah, so it means you are getting here minus 56 minus 12. So you are getting 68, right? Yeah, here it is 68. So you can, yeah, you can just make it smaller. Okay, 5x plus 2y minus 3z equal to 17. Okay, so this is equation of the required plane, and this is in Cartesian form. We need vector form also. Required plane in Cartesian form. Okay, this is the Cartesian equation of the plane. Now the vector equation of the plane is equation of the plane in vector form. Vector form is, so here, from here you can find, okay, whenever you have to find vector on Cartesian, so to find Cartesian is easier in this case. So to get vector form, what you can write, x, y, z, that is your r vector, dot, here it is a, b, c, I mean n vector, 5i plus 2j minus 3k, r dot n equal to d. Okay, so this is the equation of the plane in vector form. Okay, so today's lesson is very, you can say, the shortest session and the simplest concept we have taken, how to find equation of the plane when the plane passes through three non-collinear points. Okay, so in case you get collinear points, you cannot have the plane. So in that, how to know the points given to you are, I mean, collinear or non-collinear? So usually we do not check it. So if suppose you are get the points are collinear and you are trying to find equation using these 3 points, so you may get something like 0 equal to 0. Okay, so then obviously you will not be getting the equation there because there won't be any plane possible in that case. Okay, so basically I think you have one or two questions in NCERT textbook, so where you are getting 0 equal to 0. It means no plane is possible in that case. Practically you are not getting any equation, right? So in that case, rather than getting panic, okay, what happened? So you may think, okay, maybe these 3 points are not non-collinear. Yeah, these 3 points are collinear. That's why I am getting such result. Okay, so not to get panic, right? So basically, as long as you are strong in your concepts, you don't have to worry about the result. Okay, so thank you so much. So this is what we have to study in today's class.